Would you say the first graph is even or odd? And how do you know? Even, yep. And how do you know it's even, Kimberly? Yep, both going in the same direction. So it's even because both arrows are the same. What about positive or negative? Negative. How we know it's negative? Because the arrows are going down. Good. Last thing we need to do is write our equation in factor form. I'm going to write it at the top of the screen so that everybody can see it. Show me with your fingers how many times does this graph go through the x-axis? All right, 4. Good. So that means I'm going to make 4 parentheses. So I have f of x equals, or y equals, I'm going to make 4 sets of parentheses. 1, 2, 3, 4. Put an x in front of each one. And remember, you simply flip the sign. So wherever it crosses the x-axis, you're going to put the opposite number inside the factor. All right, so the first time it crosses through at -6, so we're going to put a +6. You got to flip the sign. So put a +6 in the first one. The second time it crosses at a -2, so I'm going to put a +2. The third time it crosses at 0. So this one, it can actually, you can just leave that x by itself. You can put +0 or -0, but whenever it's a 0, we usually just leave x by itself. And then lastly, it crosses at +3, so I'm going to put a -3. This is missing one thing, though, to get full credit on the test. Anybody know what I'm missing? Nope. The -1 in front. Anytime this is a negative, if this is a negative leading coefficient, you might want to write this somewhere so we can win. Make sure we do well on this upcoming test. You have to put a -1 in front. You only have to do that. That's why I left a space in the beginning. You only have to do that when it's a negative leading coefficient. All right, go to page 4 in your notes. We got a little bit of factoring to do, and then we will be, you might need your multiplication charts today too, because we are factoring. So page 4, let's go ahead and fill in our blanks. You have to make sure before you start factoring that you set it equal to 0. The polynomial can be factored using a lot of different methods, and we're going to talk about a lot of different methods over the next 3 or 4 days. But no matter what method we're using, we always start by looking for a greatest common factor. And then after it's completely factored, to find the solution, we set them equal to 0 and solve. All right, we got it? All right, let's go. So these first few examples have already been factored. We're only going to do A and C today, though. So you're going to start by setting your factors equal to 0. So we got, this is my first factor, x minus 3, set that equal to 0. And then my second factor is 2x minus 1, set that equal to 0. Go ahead and solve both of those equations for x. Your blue factor is going to be a fraction. All right, so I'm gonna, for this first one, because it's x minus 3, the opposite of subtraction is addition, so I'm gonna add 3. So x equals 3 would be my first answer. The second one, I'm gonna start off by adding the 1. And then to get rid of that 2, because it's being multiplied, I'm gonna divide by 2. So x equals 1/2 would be my second solution. All right, we'll skip over B and go to C. Question C has 3 factors. This is the first factor. This is my second factor. And then I have my third factor. Let's start off with 2x. So 2x equals 0. And then I have 4x minus 4 equals 0. And then I have x plus 7 equals 0. So this one has 3 answers. So for the first one, I have to divide by 2. What do you think 0 divided by 2 is? 0 divided by 2. Do you think that's 0? Or do you think that's 2? Who says 0? Who says 2? It is 0. Good job. So x equals 0 is my first answer. For the second one, I have to do 2 things. First, I need to add the 4. And then I have to divide by 4. So x equals 4 divided by 4. And what is 4 divided by 4? 4 divided by 4 is 1. Good. That would be my second answer. And then for my third answer, is somebody knocking at the door? No? Okay. For my third answer, I subtract 7. So then x equals -7 would be my third solution. These were already factored because they were in parentheses. For the next 4 examples, though, we have to factor them. And we're going to follow the same 3 steps. Set it equal to 0, look for a GCF, and then factor. All right, so let's go ahead and get started. Let's look at this first one, example A. I'm going to break this down because that might be helpful. X squared is the same as x times x, and then that's plus 2 times x. That's what that is. That's the factors. So we have 2 different terms. And what is the GCF that they both have? What can I take away from both of those terms? X. So that would be my GCF. So my GCF is x. Let's put that here. I'm going to add a line, though. I'm going to add factors. So that x is my first factor. My second factor is what's left over after I take out the GCF. And what's left over is x plus 2. So now set those equal to 0. Set the red x equal to 0. X plus 2 equal to 0. So this one, we don't have to do anything. This is already solved, so that would be my first solution. But for the second one, I have to subtract 2. So that would be my 2 solutions. All right, let's look at our next example. So let's look at question B. So if I break this down, this would be 3 and then x times x times x minus 6x squared, which is the same as 3 times 2 times x times x. All right, go ahead and look at that. Take out your GCF. So we're looking for what they both have. So what do they both have? We know we could take out a 3. How many x's can I take away? 2. Yeah. So my GCF would be 3x squared. That's what 3xx is. 3xx is 3x squared. So my factors would be 3x squared. And then what do I have left? X, a minus sign, and a 2. That's what I would keep inside of my parentheses. All right, let's go ahead and solve these. So if I have 3x squared equals 0, and then I have the x minus 2 equals 0. So for the 3x squared, I'm going to divide by 3 first. 0 divided by 3 is 0. And the opposite of squaring a number is to take the square root. And the square root of 0 is 0. So that would be my first solution. Go ahead and solve the second one. So x equals 2 would be your second one. So 0 and 2. All right, we're going to skip over C. Let's go to D. Oh, sorry. So we're on example 2 now. So we're going to go to part B. That's what I meant to say. So now let's do some that are a little bit harder. Notice that this one is not equal to 0. So what I have to do first is subtract 6b from its like term, which would be 10b. So then that'll give me 2b squared minus 16b equals 30. Sorry, not equals 30. Plus 30 equals 0. You can just set on my desk. Now we need to look for a GCF. So remember, we start by setting it equal to 0, and then we look for our greatest common factor. What number can I divide into 2, 16, and 30? 2. So that would be my GCF. My GCF is 2. So I'm going to divide everything by 2. So that would be b squared minus 8b plus 15 equals 0. A, B, C. I'm going to go ahead and put that 2 that I took out. I'm going to put that right there. So we need to factor this down though. So we need 2 numbers that would multiply to give you 15, but add to -8. Oh, I didn't even hear that. So let's go ahead and think of our 2 numbers that multiply to be 15 and add to -8. Feel free to look at your multiplication chart if you need help finding those numbers. 2 numbers that multiply to 15. Just give me a thumbs up when you know the numbers. Don't say them out loud. I need 2 numbers that multiply to 15, but add to give you -8. All right, what's my numbers? Who wants to give them to me? Lariah, what you get? -5 and +3, or -5 and -3?
-5.
All right, -5, -3. So now we need to make our box. And we have our b squared, and we have our 15. And we got to put those numbers here and here. Go ahead and take out your GCF. Let me go ahead and break down that box just in case somebody needs me to. So this has a b and a b, a 3 and a b, a 5 and a b, and a 3 and a 5. Go ahead, take out your GCFs. Look at each column, and then look at each row. So we got a B that comes out first. And then this second column, or second row, I could take out a 5. But it's going to be a -5 because it's touching a -5. So B minus 5, that's my first factor. Now my second factor, sorry, because my first factor was the GCF. And then we have a B again. And we have a 3, except it has to be a -3. So those will be my factors. Your last step will be to set all factors equal to 0. But notice how this first factor does not have a B. So I don't need to set this equal to 0. We only have to set these two equal to 0. So B minus 5 equals 0. B minus 3. The factor has to have a variable in it in order to give you a solution. So I'm going to add the 5. And then I'm going to add the 3. So my two solutions would be B equals 5 and 3. All right, just one more question and then we will end there for today. I'm not passing out homework 2 yet. Actually, we skipped over homework 2. It's homework 3. But remember, homework 1 is due tomorrow. Recording for yesterday is posted so you can watch that. What'd you say? Somebody say something? No? Okay, I'm tripping. Okay. All right, let's see. I want to do this one here. We'll end with that one. Let's go to question D. Last one for today. So, does this one equal 0? Does it equal 0 at the end? Nope. So we got to start by adding 2n. And I need to add that to my like term, which in this example would be the -8n. So that would be 2n cubed minus 4n squared. -8 plus 2 is -6n. So now it equals 0. Let's go ahead and find our GCF. What do you think I'm taking out of all three of those terms? A 2. I agree. What else can I take out? I could take out a 2, and what else? Can I take out an n? Because remember, this first one has 3 n's. This one has 2 n's. And this third one has 1 n. So they all have at least 1 n that I can take out. So my GCF would be 2n. So I'm going to divide every single term by my GCF. So I'm going to put a 2n. That's my first factor. So that will be, I'm dividing the numbers, subtracting my exponents. So that would be n squared minus 2n minus 3. So I need two numbers that would multiply to be -3 and add to -2. What would be my two numbers? They multiply to be -3 and add to -2. 3 and 1, which one do I make negative, the 3 or the 1? Not the 1. Because see how it has to add to a negative number? So the bigger number is negative. So we're going to put our -3 in and our +1 in. And when we take out our GCFs, we have an n -3 and an n + 1. But this one is a little bit different though. If I go back to this example, I'll be right back to that one here. Notice that for this last one, we didn't have an n. That's why we didn't have to set this one equal to 0 because it didn't have a b. I'm sorry, we used a different letter. But for question D, all three factors have a variable. So we got to set all three of these equal to 0. We have to set this equal to 0. This needs to be set equal to 0. And this needs to be set equal to 0. So let's go ahead and do that. So 2n equals 0. N -3 equals 0. N + 1 equals 0. So I'm going to divide by 2. 0 divided by 2 is 0. And then I'm going to add the 3. N equals 3. And then lastly, I'm going to subtract 1. N equals -1.